Welcome back. So in our last episode, we talked about how we install a vanilla Authentik server, what vulnerabilities are there, and how can we exploit them, and show proof in how to exploit them. In today's episode, we're going to be talking about locking down Authentik so that the vulnerabilities that we displayed lock down and we have a more secure environment to work with. So let's begin. All right, for our next step here, we're going to start fixing and hardening our Authentik server. So the first thing we're going to do is the localhost bind. So we have our Authentik server and containers listening everywhere. We have the quad 0, which means that everyone and their grandma can connect to Authentik. We want to change that, right? So what we're going to do here is that we're going to be changing how the metric is going to be listened to and how the debug ports are going to be listened to. And we're going to make it all internal. So only localhost can have access to the metrics and debug ports. Let's silently validate that actually happened. Yep. So this was added at the very bottom here, or in the very bottom of the environment file. So this is good. Really, so one of the things we need to knock out here is that Authentik defaults to no explicit log level, which means someone or some misconfiguration blueprint somewhere can flip it to trace. The trace logging dumps session cookies into log stream. One line prevents that. We're basically adding this pins the log level to info explicitly. Without this, the log level is controlled at runtime. It can change to trace or debug via the admin UI or the API. This was a fun find. By the way, an Authentik means full session cookies appear in the container logs. So let's change that in the environment file. And let's verify that. Yep, that has been added twice. Looks like something got bled through in my work. So we need to delete the second Authentik log level info. We need to delete that because that comes up twice in my environment file. So I'm going to do a sed. We're going to go into the environment file and we're going to delete one line right here. So let's do that. And now let's do a cat and Authentik. And then .environment. All right, so info, yeah, everything looks good. All right, so there's no double log. Sweet. All right, so now that we have added our 4 lines, which is the info and the metrics and debug ports have now been localhost, let's restart our Docker Compose file for Authentik. Oh. And then because the reason that failed was because I wasn't in the Docker Compose folder where the Compose file is located at. I was in my root home directory. I need to go to in my case, the Authentik folder, and then run the Docker Compose restart. All right, so next we're going to clear this bad boy up, and we're going to validate that the work that we just did regarding the metrics ports is now listing internal only. All right, so that's good. Look at that. Very good. Okay, so we validate that we locked down the metrics and the debug port. So I think this is one of the findings in the prove it and break it video that we just closed. So this is excellent. So let's clear this up and move on to the next vulnerability. All right, so this is one of the big ones. The other one is OpenBAO, but this is one of the big ones that we want to work on for securing up Authentik. And that is a reverse proxy. One, we validated in the last video that Authentik can't add its own security headers. Maybe it can with the newer versions, which I think there's 2 releases since 2025, 12.3. But at the moment, those are not in the version that we're running right now. It can't block its own dangerous API endpoints. We found that with the blueprint and expression policies. It does not rate limit on its own login flow, which is problematic, right? We can do a DDoS of all kinds to break that system. So one of the things I want to recommend is that we put that HAProxy right in front and let's, validate, is it even installed on my machine here? Because like I said, I have tested this many times between the prove it, break it, and this video. So let's see if it's even installed or not. It is not installed. Yay! can't tell you how many times I forgot about this line right here when I did the demo or when I was researching and testing this out between the videos. And trust me, this broke me a few times. So now we're going to do the install of HAProxy. So we're going to do our apt, and we're going to install HAProxy. All right, so this was installed. So luckily, HAProxy was not installed prior to this video. Lucky me. And so now let's validate that everything is functional. So we're going to find out what version and what status is of HAProxy. All right, so it's running. Good. All right, so one of the things we found is that this bad boy is installed, but if I were to type in HAProxy, it is not going to run. See, command not found. So I need to look and find out where the path is for HAProxy and then assign that into my bash. Can't always be perfect when you do these installs. We're going to do a which and then version. There we go. Look at that beauty. Oh, look at that. So now the command works. Yay! We're superstars. All right, so we validated that HAProxy lives like Frankenstein. It's currently running in a totally default vanilla config that ships with its install. We're about to replace that with a config that blocks 6 attack surfaces. We're going to be adding every security header that Authentik can't address with itself. We're going to create some rate limiting. We're going to do all sorts of great stuff in here. One file, probably the most valuable single file in this entire hardening. If we don't include OpenBAO, which is our secrets manager. All right, so next thing we're going to do is we're going to create a copy of our vanilla config because you never know when you may need to go back to it and rebuild. Even though we probably never want to use the vanilla config file, we need something to go back to because, oh geez Louise, if we use the default and modify the existing vanilla config, then that would be problematic because we have nothing to go back to. So best practices, backup every. So now that we create a backup, let's clear this up. Now we're ready to modify the HAProxy that's there. So let's look at that. The first set of configuration is the maximum connection to our HAProxy 4096, which is way below in which I'll ever use HAProxy unless I'm doing performance engineering. This is not related to this episode. End of the Authentik server, we're going to bind port 80. What we have here for finding 08 is this basically deletes any incoming XFF and replace it with the real source IP. This basically prevents IP spoofing. This is the CSP, HSTS, the X-frame options, no sniff. These are options and security headers that we can't configure natively on Authentik, and we need to set explicitly in our HAProxy. Finding one is going to be blocking any requests going to our HAProxy. We're going to be blocking any API requests to /metrics on the HAProxy. So there's not a real reason why someone would need access to this at the moment. There are use cases to have metrics, but by default with this vanilla setup, we're going to be blocking that. The next set, we're going to be blocking our expression policies. Remember when we did this and prove it and break it, there was a lot of things that we could do and break within the system if we allow these two to stay open. So if you need to leave this out and you need to let people have access to this, narrow down to your IP. And this is the biggie that we found in our last video, the blueprints API. This is basically policy as code. And if we leave this wide open, there's a lot of hidden things that we can do and use with blueprints. Even though a blueprint can create an expression policy and thus create a user, even if you delete that user, the blueprint will still be there and it can be called upon. So we want to block this. We definitely want to block CAPTCHA calls. It's not needed. We want to create some rate limiting on our just an HAProxy. We are saying on the backend Authentik line here, we're saying that Authentik is only going to be listening in the backend on port 9000, and that's it. HAProxy will be doing the secure or encrypted termination, and then we'll forward the traffic to Authentik. All right, so let's grab this, and now let's go back to our Authentik server, and we enter. Now let's make sure that was actually received on the config. All right, so I did. So there is our validation. So all the things that we submitted have now been kept. Sweet. Let's validate that that HAProxy will run this config. All right, so no response is good response, because if there was an error, you would have gotten a lot of error messaging right here. So this is a good step. We just validated our config. All right, so now let's clear this up and let's reload. Okay, so everything is still looking good. Look at that. Perfect. So let's clear this up. And now, here's the thing though. But if HAProxy is alive, Authentik doesn't really know it exists yet. Right now, the trusted proxy is set to localhost only, which was better than the default quad 0. But now that HAProxy is the thing sitting in front of Authentik, and we need to tell Authentik to trust the headers from HAProxy specifically. Since they're on the same box, that's still localhost, not a big deal, but let's be explicit about it. So here we're going to look at the environment file, and so we can see here that we have our trusted proxy CIDR, so it's localhost only. Let's make sure if we can get to our metrics API. So if we did this even on the Authentik server, it's going to be a 403, because remember we're blocking it via HAProxy. So that got blocked. That's where that 403 is occurring. Next one we're going to test here is going to be seeing if we can get to the expression policy API call. So we got our expression policy, and this is going to go straight to the HAProxy. Now that we validated that metrics is blocked, expression or policy expressions are blocked, let's clear this up and let's test our other 3 blocks, which is our property mappings, our blueprints, and our CAPTCHA API calls. All right, so they all are blocked. Yay! That is very good. And so now we need to check the security headers are actually being injected on responses that do pass through. So what we got here is that what we wanted is to make sure that certain criteria is being blocked and enforced, and we just validated that. So no sniffing, X-frame is being denied. So let's clear this up. So next we're going to be adding a TLS cert onto our HAProxy. First, we need to make a folder for our certs. Okay, we're now going to be creating our self-signed cert with the host IP and a validation of 365 days. Okay, so this is now our... Okay, there is our self-signed cert. Now we're going to combine the key and the cert together to make a PIM file. We're basically going to lock it down to only the file owner at this point after that. So we have our cert ready. Now we need to change 2 lines in the config. We need to bind our port 443 with the cert and redirect anything that hits port 80 to port 443, which is HTTPS, but otherwise everything stays the same. So let's do that. We're going to do a sed, or we're basically saying anything that comes in via HTTP is going to get redirected to HTTPS, and we're going to be binding our port 443 with our cert. Okay, this looks good. So next we're going to verify that everything was submitted over to the HAProxy config. Let's see what we've got. All right, so everything is bound. We got our 443 with our cert, and we're redirecting anything that comes in for HTTP to HTTPS, which is good. Now we're going to validate, and then we're going to reload. Okay, so this right here, what this is saying is that these are warnings, they're not errors, and it's still running. But the thing is that HAProxy is basically telling me that redirect line is in the wrong spot. It's processing the HTTP request rules before the redirects ever happen, but it wants the config to reflect that order. So that's fair. All right, so let's change our config. Actually, let's look at our config. So let's clear this up. And we're going to do a cat. Okay. So this is what it's firing about. It's firing about the placement. All right. Good to know. So it wants us to remove this redirect down below here. And that's what it's really saying, is that it's asking us to move our redirect. So we can do that. So let's clear this up. So here we're going to be doing a set. The first line is that we're going to be deleting the redirect line from its current position. And the second line, we're basically reinserting it just before default backend at the very bottom, after all the HTTP requests and HTTP response rules. Okay, let's look at that, cat. Look at that. It's all, this is the way it wanted it to be. All right. Okay, no error here. That's good. That's a good sign. And let's reload. So no warnings. What we want. Let's make sure the HTTPS is actually alive and the redirect works. So let's do a curl. We got that 200, so that's good. Okay, next we're gonna, even though we did a curl, let's make sure the browser, what's value we can get to via the browser. Over here. Okay, so we got our self-signed cert. Okay, so this is not an HAProxy error. This is an Authentik error. Interesting. Let's get out of that. Let's clear this. Oh boy, troubleshooting. So right here, what this does is that the first command here is going to show the HTTP status code. The second shows the actual response by, so we can see the error that Authentik is throwing out. We need to do this to investigate why we're getting that error that we saw. Okay, that's interesting. Okay, so this is showing that everything's functioning. Okay, that 200, and we're hitting it. So let's test out that redirect. Okay, we get that 301. Okay, let's revalidate the API calls that we saw earlier, which is the metrics, expression policy, property mappings, blueprint, CAPTCHA. We got our 403s, so HAProxy is doing that. And then our security headers. Okay, so something is blocking us. So let's clear this. And let's see if we can get straight to Authentik via its normal port of 9000. Okay. All right, so let's go back over here again and see this error. So this is we're getting to Authentik. What if we go straight? If we go straight to the server and we go 9000. Okay, so we can get here. I mean, log in. We can. I mean, this is. Can we get? Is that working all the way through? This has something to do with the CSP header. Okay. Okay, this is good. Good. Let's loosen the CSP policy and see if that's the culprit or not. My money's on CSP. And now let's reload. Okay, everything has been, no errors here. Okay, so let's look at our HAProxy config again. So we turned off CSP profile. Let's turn off our let's turn this off right here. Let's make sure that okay, so there's a dupe right here. There's two of these, and we just deleted one. So we need to delete that last one again. Okay, let's count how many times that shows up. Okay, we need a sudo. All right, so we go down below. Let's make sure. Okay, no longer there. So we had to go through nano. And I'm pretty sure that I could have probably deleted that with the sed. Well, I did do the sed with the sudo. Well, sometimes going nano is the way to go. Okay, let's clear this up, and now let's validate that this will run without any issues. Okay, and then we're gonna reload. Okay, now let's go back to our jump server and let's try this again. Okay, I have one. We're gonna have one in there, which is good. Let's compile and reload. Now let's go back to our jump box. Let's see. Oh, look at that. So there was multiple X forwards right there. Okay, so that was the issue. So the original issue we saw here was that we had multiple entries for our X forward, and we only need one. One would allow it, but the other two would delete it. So that was half our problem there. Let's look at the script I have. Yeah, there was only one. Interesting. Okay. Maybe when I pasted it, something got caught. Memory? Well, I've seen weirder things, but okay. All right. Well, so this is now working. Okay. We can log in. All right. So basically, the 3 copies would cause the issue. All right. Okay. So we can close out this, and we can say that we have closed a few of the vulnerabilities, and we can move on to OpenBAO now. So what we're going to do here is see what KV engine mounts are on the OpenBAO system. So there are 2, and we're going to focus on dumping our secret and password in the Authentik KV engine mount. Now keep in mind that the source of truth will always be living on OpenBAO, but just for your information, the flow is going to be that when a Docker Compose file will spin up, it will also point to a script that I will show you later. And that script will pull the secrets and password into a lockdown file. And the thing is to keep in mind about those 2 log files with secret and password is that those are going to be locked down to root only. It's not going to be world readable like an environment file. So what's going to happen here next, now that we know we have a mount or a KV engine mount that we can point to, we have 2 secrets that need to go into the vault, the secret key and the password. These current values are currently sitting in the environment file that we have seen a few moments ago. So after this, the source of truth will no longer be in the environment file. It will be in the OpenBAO secrets manager. So let's write the secrets and password into the vault. So from here, we're going to push information out to the vault or to our secrets manager, in this case, OpenBAO, and we're going to be dumping data in there for our secret key and our postgrid password. Okay, secrets are stored, which is good. So now I need to create a policy that allows us to read this path and nothing else. No writes, no deletes, no listing other parts. So now we're going to create a read-only policy. So let's create that. So our first command here is that we're going to be creating a policy called Authentik read that grants read-only access to the vault. So Authentik read is going to be the policy. It's going to only have access to Authentik data config. Remember, data is a requirement within Authentik for our KV engine. And our second command here is just reading back what we posted up. Okay, so this is basically came back saying this is the new policy that we can use. So now what we're going to do here is that we're going to create a app role. Because we have the policy, now we just need to associate our policy with our app role. We can utilize this identity or this app role. So when we utilize this Authentik startup script that we'll be creating later, we'll use that to authenticate to OpenBAO and fetch our secrets. So our role that we're creating is going to be Authentik hardening. And we're going to be referencing our policy of Authentik read. And let's get our role ID. Okay, keep this in your back pocket. We're going to utilize that in a few seconds. Okay, we have the role ID now. Think of the role ID like a user ID. Now we need a secret that we can utilize. Secret, think of it like a password. There's our secret ID. So we have our role ID, which is our user, secret ID, our password. Before we get too far, I need to know what the ID is for our Authentik server and what it runs as, because that plays a part and how we store our secrets. So this is basically executing a command within Authentik, and we're trying to get the ID that what is running inside the Authentik container, which in this case is going to be UID 1000, which is Authentik. Okay, so our next step, now we know what's running inside the container, because I just had a double check. I ran into an issue when I demoed this earlier. I ran into so many issues when I was testing this out, and I ran into so many issues, so I just had to know what the user ID is inside the container. So let's make our directory. This is where we're going to dump our secrets. That's going to be locked down. So we made a folder called secrets in Authentik, and we gave a permission of 700. So let's take a look at that and what that really looks like. Next, let's clear this up. And what we're going to do here is that we're going to be creating a script called entrypoint.shell. And the first thing you're going to notice that one called vault address, which is the OpenBAO IP address. Then the next is going to be our role ID, which is our user or app role. The role ID is our user ID, and then secret ID is looked upon as like a password. We're going to authenticate to OpenBAO via our app role. So we're utilizing the variables for fetching the secrets and the password. We're going to write to inside the secrets folder that we created earlier, and then it's going to create those two files, and that's where it's going to be locked down at. And of course, just kown means that we're giving that 1000 Authentik root will have direct access to the password, and then we're going to lock down the PostgreSQL password. Okay, so now that we create our entry points shell, we create our entry point shell. Now let's test it. So we have the script, we have the folders, we have the app roles, we have everything. So let's test the entry point script and see what we get. Okay, secrets fetched. Okay, good. You know, preferably you want to do this all this on a service account. You want to do this via a service account. And just to double check, remember we saw that ID 1000 for Authentik. Let's just check what my ID is. So it's 1000, so it's good. Okay, good. We're double checking all of our work. Clear that up. Now we replace the plain text version on, so we're modifying the environment file to point to our /secrets, and then also our /secret key. Now let's verify, make sure those changes are in the environment file. So, okay. So we double check. Yep, they're there. Okay, our next point is to, now that we have the environment file, point to our secrets folder and their respective files. Now we need to make sure that the path actually exists inside the container. One volume mount. I think that we just need to create one volume. Oh, I think we need to create one volume mount. So first, let's look at what mounts we currently have in our Docker Compose file. So we see here that server and worker needs those volume mounts to see the secrets, so they can pull the secret and password to them. So let's add that. So now let's validate that both server and worker got the new mounts. Okay, they both did. So we want to look at Docker. Okay, there's both our mount for worker. How about server? Yep, there is our two mounts right there. So they got added. Very good. So here, I'm noticing something here that we probably need to update. We need to update this. And we need to update this. So we need to update a few things. And this one right here. We know where to point it. So we don't need to add it. We just need to point the key and passwords to those files. So let's update. If we were to run this right now, we would get a number of errors. We need to make sure we point to that secret file, to the secrets file and PostgreSQL password. Okay, so now that we have our app role, we have our user ID and our secret ID, username and password. Let's modify our environment file. Let's add our entry point script. And what we're going to do here is we're going to create our variables. We're going to identify, authenticate to OpenBAO using the AppRole that we've created. Identified, we're going to be fetching the secrets from OpenBAO. We're going to dump them into the secrets and PostScript password files under the secrets folder we created earlier. Let's verify that everything has been done right. Okay, everything looks good. Okay, so that we have our script here, we're going to take out our PostScript password and our secrets out of the environment file. And let's double check. Okay, so we're going to be modifying our environment file to point to our secret and our PostScript password file that we have under secrets. And let's validate. And then one more update, which is we're basically pointing to the files. Okay, and so now we need to update so now we need to go to nano docker compose. Okay, password, get rid of this, all the way over. And because then we just identify the PostScript password file, which is under secrets. Okay, make some more additions to our Docker Compose file. We're creating more file pointers to our secret and our PostScript password files. So one more update, and that is the PostScript service. We need to add another mount right here. Just like we did with the secrets down right here, we need to add that up to the PostScript right up above. Let's verify. So the PostScript password is reading from the files in the secret. Same with the secrets living in, and same with the secrets. Clear this up, and let's restart our Docker, at least our Authentik server. Okay, 7 seconds. Okay, 60 seconds done. Let's make sure everything is healthy. Created status. So this is healthy. Very, very, very good. So since we've added OpenBAO as a storage of our secrets and password, and we have a script that pulls those secrets and password into a locked file for just the owner, hopefully for your environment, you have a service account. We've validated everything is functioning, but we need to make sure that the service itself, after doing all that everything is functional. Okay, this looks good. So everything has been loaded up. So let's just double check our logs here. So no access denied. If the permissions would have been a problem with the secrets folder, you would have got a permission denied in here. In addition, if you would have left the password to be entered, remember we replaced it with file locations, you would have had a file location problem, and this would not have loaded up whatsoever because it would not have the password nor the secret to load up. You would have had to classify an unhealthy container or a rolling loop for a reboot. And that's for the server. Let's just double check our database. Okay, everything looks good. We can close this out and we can move on to our next vulnerability. Okay, so one of the things that we found out with our prove it and break it is that our passwords are very weak. And so we need to change our password policy via the API so that one, there's a length increase. We've also validated that the password that's entered, we want to make sure that it's not pawn, meaning that the password has been hacked in any way. And we want to make sure that the password is complex. So let's list all of our password policies on Authentik. Okay, minimum is 8. This is not validating that it's not a pawn password. Alphanumeric and sensitivity. Okay. So we need to change all of this. This is a vanilla setup, and this all needs to change. So we only need one API call that fixes all of this. So what we're doing here now is what we're modifying is the length of the password, which is going from 8 to 15. We're checking if the password is pawned or not. So we're going to set the true instead of false. And this right here means that if any password falls under the pond database, that it won't be tolerated whatsoever. A score threshold, so if you type in password 123, that will fail immediately. Okay, so everything has been changed, which is very good. Okay, so this is good. So this is moving forward. This will be our policy that Authentik will utilize for password validation. So let's clear this up and move on. This is closing out our password policy vulnerability, and we can move on. So the password policy has been hardened, which is really good. So our next goal is to harden the containers. Right now, they have the full 36 or 35 capabilities that are run within the container. There's no privilege restrictions there, and it's completely a writable file system. The worker runs as root, which is not a valid and good way to run our container. And we want to make sure we limit the capabilities of our container. So before we get too far ahead, let's look at our Docker container and validate some things. So there is no restriction whatsoever. Restart, unless stop. Yeah, there is absolutely no restrictions whatsoever within the vanilla Authentik server. So we need to change that. So for server, we only really need 4 capabilities. So what this does is that we're not allowing new privileges being placed in the container. So what we're saying here is that we're going to drop everything for capabilities and only allow kown, setgwid, setuid, and DAC override, and that's it. So next we're going to update the worker. Okay. Server validated. Let's validate our work. Let's see the Docker compose file longhand. Okay, post this is the database. And this doesn't look right. Command, okay. Okay, there's our security opt, cap drop, kill. Okay, that's good. That's very good. And the same with server. This is very good. Okay, it was clear. Next, we're going to do a forced restart of our Docker container. We're going to sleep for 60 seconds, and we're going to give it some time to load. And if there's any issues, it would pop up. Okay, so now let's do a Docker PS. Okay, pop, pop. All right, good. This is very good. Next, let's just validate and look through. Let's look inside the containers themselves. Okay, our capabilities are working. So everything is the way we want it. Very good. The funny thing about what we just did is that was probably one of the more strenuous things that I had work on in the lab outside of OpenBAO. And there was a lot of issues, and the kill capabilities was the one that was a discovery, not something that was part of my original lab that I was planning to put out. That was a discovery, and so I'm glad that this worked. So this is the last closeout, or this is the last vulnerability that we're gonna be closing out, and that is right now anyone can still get to Authentik directly bypassing the HAProxy, and we don't want that. We want HAProxy locked down so that only HAProxy has access. So let's do that. So here we're going to be changing in the Docker compose file. We're going to change and create the port 9000. It's just going to be pointing to itself, 127.0.0.1, and same with the secure port, which is 9443 with the 127.0.0.1. Okay, let's reboot our Docker compose file. Do a forced reboot. Restart. Now let's just make sure that everything is functioning. Another check. Yep, everything's the way we want it. So now let's get back on here. One, let's make sure that this is still functioning. Yep. And then this will fail because remember we now block 9000 and yep, everything's been blocked and Authentik is still working. Yep. So now we can definitely close this out. We can close this out and we can move on. So what we have done so far is that all the vulnerabilities that we have found in the previous episodes, we have now closed them out, from moving our secrets and passwords to the OpenBAO for a secrets manager and pulling that information into a locked folder that's locked down, to putting HAProxy in front of Authentik and blocking particular APIs from calling into Authentik. And in addition, locking down Authentik so that everyone has to come through HAProxy. You can't bypass it. It's all locked down. In closing, I hope you found this valuable, and I look forward to you in the next episode.